Okay, hope everybody's having a good day. If you're struggling with this worksheet, I'll kind of work through it here in this video, so feel free to follow along. So for these warm-up problems, it's all about just adding and combining fractions. So for this first one, right, we kind of just we can start with this 1/2 plus 1/4 equals x. Let's just try rewriting 1/2, right? We can take 1/2, and if we multiply the top and bottom by like 2/2, right, we can rewrite it as just 2/4. So 1/2 is the same as 2/4, so we can do 2/4 plus 1/4 equals x. So we see I can only add together fractions if they have the same denominator, and here they both have 4. So in this case, we know that x is 3/4. So let's do the same thing and substitute x in right here. So we get 3/4 plus 1/8 equals y. Okay. So what I'm going to do now is I'm going to do the same thing to 3/4, where I'm going to make the denominator 8 by multiplying the top and bottom by 2. So 3/4 is the same as 6/8 plus 1/8 equals y. So y is just 7/8. Cool. Okay, second one, a little trickier. Let's isolate this 5/x on one side. So we'll have 5/x equals 2/3, and I'm just going to subtract 1/4 from each side. So over here on the right side, I got to combine these two. So let's just make the denominators both 12, right? Because that is the easiest way we can do it. We can multiply the top and bottom of the 2/3 by 4, right? So we do like 2 times 4 over 3 times 4. And then over here, we can multiply the top and bottoms by 3. So we have 1 times 3 over 4 times 3. So I get 5/x equals 8/12 minus 3/12. So here I just get 5/x equals 5/12, right? And here at this step, like, we could do cross multiplying and figure it out, but we see 5/x equals 5/12, so pretty simple. X is just 12. Okay, let's do this next one. So this one's gonna be similar. We'll start by doing minus 5/6 to both sides. So we get 3/x equals 7/4 minus 5/6, right? So it's all about finding like this least common multiple. So let's multiply the 7/4. We'll multiply both those by 6, right? So we get 3/x equals 7 times 6, right, which is 42, all over 24, right, which is 6 times 4. And then for the 5 and the 6, we'll multiply both of these by 4, right? So we'd have minus 4 times 5 is 20 over 24. So now we have 3/x equals 22 over 24. And now here I can do kind of this cross multiplying, right? I can do this 3 times 24, right? I can do something like that, right? So I get 22x equals 3 times 24, right, which is 72, right? So here I can say x equals 72 over 22, right, which is really just going to be 36 over 11. And I think that is all I can do to simplify it. Okay, let's try this last one here. So here we have 2 x's for this one, so it's a little trickier. Now let's try to combine these two fractions right here, the x/6 and the minus 2/x. So we would get something. So let me write this out again. So we have x/6 minus 2/x. So let's try to get my denominators to be the same. So I think if I make them both 6x, that's probably the easiest way I could do this, right? So to do this, I'm going to multiply this left fraction, this x/6, just by x/x. And then this one, I'll multiply by 6/6. So now I would have x squared over 6x equals, minus 12 over 6x. Cool. Equals 2/3. So now we can kind of do this here. We could say, all right, x squared minus 12, we can combine this now, over 6x equals 2/3. And now I'm going to multiply both sides by 6x, so I would get x squared minus 12, and then 2/3 times 6x is just 4x. So now I'm going to bring this 4x over to the left, so I'd have x squared minus 12 minus 4x equals 0. I'm going to rewrite it, so it's x squared minus 4x minus 12 equals 0. And this we can go and factor, right? We can factor this here. We can say, all right, this is just x minus 6, and then x plus 2. Right? Okay, so here we really have our two answers, right? X equals 6 and x equals -2. Let's go ahead and check this real quick. So let's do x equals 6, right? So we'd get, if I plug in right here, I would have 6 over 6 minus 2 over 6 equals 2/3. That looks good because we have 1 minus 1/3. 2 6 1/3 equals 2/3, right? So that looks good. So what if I do -2, right? So -2 over 6 minus minus 2 over -2. So I just made x -2 here. Equals 2/3. So this would be -1/3. And this actually ends up just being plus 1, right? Because it's minus -1, right? Equals 2/3. And that also works. Okay, let's go to the next page. So this stuff's pretty similar, right? Where we're kind of just looking at adding and subtracting rational functions, right? So if I've got two rational equations like 3 over x plus 2 and 5 over x plus 3, and if I want to combine them, I have to find something that would make the denominator the same. So usually what we do is we'll kind of multiply it by like the other fractions denominator. So in this case, if I have 3 over x plus 2 and I want to add together 5 over x plus 3, for the 3 over x plus 2, if I multiply the top and bottom by x plus 3, and for this one, if I multiply the top and bottom by x plus 2, right, now you see the denominator is the same for both. I've got x plus 2 times x plus 3, and now I can add these together, right, because we need to have the same denominator to add these together. Cool. So now we can finish simplifying. So all I really need to do is just say, all right, this is 3x plus 9, right, that's this here, over x plus 2, x plus 3, right? I'm just going to leave it in this factored form. And then here I'm really just going to do plus 5x plus 10. And here, since they have the same denominator, I can combine them all into one fraction, right? So this is one of the traits I can do with fractions. So let me just simplify this fully. So 3x and 5x, that's 8x plus 19 over x plus 2 times x plus 3. So this right here is going to be equivalent to this up here, right? Those are equivalent statements. Okay, now this is in the most fully simplified form we can get. So now I can find my asymptotes, right? So it seems like my vertical asymptotes will be very easy since it's already factored in my denominator, right? So we would have x equals -2 and x equals -3. So I'd have two vertical asymptotes. My horizontal asymptote, right? So if I were to factor this out, right, I would have like 8x plus 19 over x squared plus 5x plus 6, right? And remember our rule, right? If the degree of the term on my denominator, or the highest degree of my denominator, is bigger than the degree of the highest term in my numerator, right, then my horizontal asymptote is just y equals 0, right? Since x squared is bigger than 8x, right, we're going to be approaching 0 as x goes to infinity and -infinity. All right, so my x-intercept is just what makes y 0, right? So we just need to say what makes the numerator 0 is kind of what we're looking for, right? What makes 8x plus 19 equal to 0. So what we can do is we can just say 8x plus 19 equal to 0, right? And then we can just solve for x. So I get 8x equals -19. So x is -19 over 8. So I would have this coordinate, right, -19 over 8, comma 0, right? when y is 0, x is that. Now the y-intercept, for the y-intercept, we just got to make x 0, so I'm going to go off of this form right here. So I'll just do 8 times 0 is 0, right, plus 19 over 0 plus 2, so 2 times 3. So really, 0 and 0, so I get y equals 19 over 6, right? So my y-intercept would have the coordinate 0, 19 over 6. Cool. Okay, so we have all the key elements of this graph right here. So let me move on to the next page, right? Okay, so here, right, we have a rational function and we want to combine them using the same technique we have been using, right? So let's do this right here. So if I have, let me just rewrite this, 5 over x plus 5 plus 4 over 2x minus 6. So for this one, right, I'm just going to multiply the top and bottom by 2x minus 6. And then over here, right, we'll do x plus 5. So I would get, this would give us 10x minus 30, and it's all going to be over 2x minus 6, x plus 5. And then this is going to give us plus 4x plus 20, right? So really, I just combined these into one big fraction just like that, right? So I did this distributing here, right? And since it's all over the same denominator, we can combine them. That's why I was able to combine them right here. So my final answer, right, would just be 10x plus 4x, 14x, negative 30 plus 20, so 14x minus 10 over 2x minus 6, right, x plus 5. Okay. So let's find some of our key elements of our graph. So vertical asymptote, right? What makes the denominator 0 since it's already factored, right? For this one, right, we see if x equals 3, that's going to make this 0. For this one, we'd have x equals negative 5. So I'm going to have two vertical asymptotes. Similar thing here, right, for my horizontal asymptote, right, if I were to FOIL this out, you see I'd get 2x squared, which is going to be bigger than 14x, right, which is the term that has the highest degree up here. So here I would have just y equals 0. Okay, x-intercept, what makes this top part 0? So we can just say 0 equals 14x minus 10. So I would get 10 equals 14x, or x equals 10 over 14, right, which is the same as 5/7. So I would have the coordinate 5 over 7, 0. And then for my y-intercept, right, let's just plug this in. I would get y equals 14 times 0, so I just make x 0. So I'd have negative 10 over, sorry, I'm kind of running out of room here, negative 6, right, because I make 2 times 0 is 0, negative 6 times 5. So it's really negative 10 over negative 30, or just 1/3. So I would have the coordinate 0, 1/3. Okay, so we can plot this on our graph. So right here, I'm just saying this rational function is pretty tricky to graph. So what I would recommend doing, right, is just kind of write out our asymptotes and our intercepts, and then we can use Desmos to help us out with the rest. So let me plot here. This is my first x equals 3. And we have x equals negative 5 right here. So I've got two vertical asymptotes and one horizontal asymptote right on the x-axis, right? Y equals 0, right? So even though I have a horizontal asymptote of y equals 0, right, I'm actually still able to cross the x-axis, right, with this x-intercept, right? So here I have this coordinate 5 over 7, 0. So that's like 5/7 is going to be like right over here. So I can cross here. All that matters with the horizontal asymptote is what happens in the long term, right? What is y approaching as x gets really big. So in like the middle here, I can like cross my horizontal asymptote. All we care about is the end behavior for my horizontal asymptote. And then my, let's see, where's my y-intercept? 0, 1/3. That's like right there. So what we could do is we could plot this in Desmos and just kind of graph this function, right? So that's what I would recommend doing for this one. So let me do this real fast. Okay. oh, I'm sorry, I did negative 1/3, it's supposed to be right there. So this is kind of what my function will look like. It's gonna be, like this is this middle part, right? It's gonna go right there, and then I will have these two sections kind of just like here. We could plug in additional points and try to get a better estimate of what this would look like, but this is a good rough estimate of what my rational function looks like. So for this one, right, let me just do this very fast, right? So this would just be 3 over x plus 7 plus 4 over x minus 8. So over here, right, let's multiply both by x minus 8, and then over here, we could do x plus 7, x plus 7, right? So I would have over here, right, I would have 3x minus 24 over x minus 8, x plus 7, right? And then plus 4x plus 28 over x minus 8, x plus 7. So if I combine these, now they have the same denominator, right? We would get 7x, right? 3x and 4x, and then negative 24 plus 28, just plus 4 over x minus 8, x plus 7. Okay, great. So that's kind of the most factored form we can get. So vertical asymptotes, right? We'd have x equals 8, x equals negative 7. Horizontal asymptote, once again, is going to be y equals 0. X-intercept, right? We can just say 7x plus 4 equals 0. So we would get x 7x equals negative 4. So x equals negative 4 over 7. So my coordinate would be negative 4/7, comma 0. My y-intercept, we can just say y equals 7 times 0, 0. So 4 for negative 8 times 7. So it's really going to be 4 over negative 56, right? Okay, so that's what we get for my y-intercept, right? That's going to be this right here. Okay, so we can plot our kind of points here. So we have x equals 8 right here, x equals negative 7. And now we can kind of give a rough idea as to what everything looks like. So we've got negative 4/7, comma 0. So that will be like right around here. And then we'll have one like down here as well. Right, so this is this dot right here, that's this point. And then this one on the y-axis is my y-intercept. So my function is going to end up looking something like this. Highly recommend you plot this in Desmos and check, right, and see what the rest of it looks like. These can be very tricky to graph without doing so. So don't worry too much if you're struggling with graphing these hard ones, right? Use the tools that you have. Okay, let me plot our horizontal asymptote. Y equals 0, and the rest of my function will just look like this. Okay, hopefully this video was helpful. I'll be back tomorrow, so if you have any questions, feel free to ask on Thursday or Friday. Awesome, have a great class.